This is the HYSYS simulation of a continuous stirred tank reactor, a CSTR, and the instructions for setting up this simulation are in Appendix 4.1. So we're going to use this simulation to look at the energy balance over a CSTR. So we need to look at the reactor feed stream, and we need to adjust the temperature of this stream to 25 degrees Celsius, and the reactor product stream to 25 degrees Celsius. We'll leave the pressure the same. Because this is a continuously stirred tank reactor and we employ the assumption that it is well mixed, by setting the liquid product temperature to 25 degrees Celsius, we effectively set the temperature of all the material within the vessel to 25 degrees Celsius, and we can see this here. So if we now look at this coolant stream, we can see that the duty is about 830 kilowatts. So we need to take out 830 kilojoules per second of energy to maintain the temperature of the reactor at 25 degrees Celsius. In our hand calculations, we calculated a value of 798 kilowatts, and the difference between the two is largely due to the assumptions that we make in doing our hand calculations. We can also see that if we look at the conversion of the reaction, here it is 46.75%, and this varies slightly to the conversion that we calculated in our hand calculation as well.